Greetings, Saintsmen. Today we're going to do our lesson 3.3 on function notation. So let's go ahead and get started. Function notation, I'm going to do this with a linear function. So we start with a slope-intercept form, and this is also going to be our function form. So the difference here is that we have a linear equation in what's called slope-intercept form. And if you don't know what that means yet, that's okay. We're going to go over that later in this chapter. But you may be familiar with that form already. This is the difference. Here's function notation. The f of x is equal to mx plus b. And here is function form. Excellent. What's it? What's the difference? Well, it's that we have y and we have f of x, and guess what? They're the same thing. Okay? F of x and y are the same exact thing. What this does not mean, this is f of x. And what this does not mean is f times x. Another way to say this is the function which is named f when x is happening. Okay? So that's what this is. This f is the function f. Okay? That's just its name. We can do the g of x, we can do the L of x, we can do any letter there. And we will later in this course. So let's evaluate a few things. We're going to evaluate the f of x when x is equal to, when the equation is 2x minus 7 and x is equal to negative 4. Okay, so the way we do this is we're going to substitute in for x. Okay, every time that we have x, we are going to substitute in negative 4 now. Okay. So rewriting this whole guy, 2 times, again, negative 4. And when I replace something, I put it in parentheses, okay? So minus 7. So the f of negative 4, which I don't have to necessarily rewrite the whole thing, right? I can just rewrite this at the bottom. Just keep the equal sign continuing down in the middle. 8 times, right here, like have this little line for the equals, okay? Just line that guy up. 2 times negative 4 being negative 8, right? And then minus 7, which is going to give me negative 8 minus 7 is negative 15. So what this says is that the f of negative 4 is 15. This is our answer. Or the other way we could have written that is that the f of x, the function named f, of x is equal to, or when, is negative 15 when x is equal to negative 4. Both of these answers are correct. Okay? Doesn't matter to me which one is used. But I actually prefer the first one because it does a couple things. First of all, I have an ordered pair there, right? I have the f of negative 4. So in other words, x is negative 4, and my y would be negative 15. So it'd be negative 4 comma negative 15. It's also just less to write, but either thing is permissible. It's fine. Okay. Let's do a different function here. So we're going to let the f of, move our writing up here. We're going to let the f of t be the function for the outside temperature in degrees Fahrenheit, which is T hours after 10 a.m. We're going to explain the meaning of each statement, okay? So this is what we're going to do. First of all, the first problem, we're going to take the f of 0 is equal to 75. Second problem we're going to do is we're going to say the f of 3 is equal to n. And the third problem we're going to take is the f of 1 is greater than the f of 8. And we're going to decode, because we're in function notation, what each of these means. Okay, so the first one. Well, if t is time after 10 a.m., and t is equal, in this case, right here, t is 0. This means t equals 0. Well, 0 hours after 10 a.m. is 10 a.m. So at 10 a.m., the degrees Fahrenheit is 75 degrees. That's it. How about the f of 3? Well, this is 3 hours after 10 a.m., which means at 1 p.m., which is 3 hours after 10 a.m., the temperature is n degrees Fahrenheit. The next one, the f of 1, which means this right here literally means 1 hour after 10, or in other words, it means 11 a.m. And the f of 8 is 8 hours after 10 a.m., which is 6 p.m. So 11 a.m. is hotter than 6 p.m. That's the difference. That's it. Okay, remember, we're just saying f of x, but of course we can name the function whatever we want, whatever letter we want. So let's do the g of x. It's another common one we'll see, which is equal to negative x minus 1. So here's your function. Now we're going to evaluate a few different scenarios. We're going to evaluate the function. And the name of the function is g. When x is equal to negative 4, 0, and 3. All right, so first one we want is the g of negative 4. Well, g of negative 4 is equal to negative, and inside the parentheses, we're going to put negative 4, right? Minus 1. Negative 4 is 4 minus 1, which is equal to 3. So in other words, the g of negative 4 is equal to 3. Or, of course, you could say the g of x is equal to 3 when x is equal to negative 4. That could also be your answer right there, too. Okay? But, of course, you're going to have to show all of this work that's up above. So, next, let's find the g of 0, which is going to be negative 0 minus 1. In that case, 0 minus 1, because negative 0 is 0, it's going to be negative 1. So, in other words, the g of 0 is negative 1, or the g of x is equal to negative 1 when x is equal to 0. That's your answer. Again, we have one more of these guys to do. Evaluate the g of 3, of course, and then it's going to be negative 3 minus 1. Minus 3 minus 1 is going to be negative 4. So the g of x is equal to negative 4, right? When x is equal to negative 4. I'm sorry, when x is equal to 3. We input 3. My apologies. I misspoke. All right. Let's do a new one. Let's graph. We're going to graph the g of x and a different function being 3x minus 2. Okay, again, I am a big fan of the vertical table when we evaluate. Now, we have some freedom here, and that's where people get uncomfortable. They get uncomfortable with freedom. So we have x and y. In this case, it's the function, the g of x, right? It's the same thing as y, as we established. And we have so much freedom with this, we can input any values we want. What's great about this particular methodology is for every type of function, now the parent function here that we're working with, it's called a parent function, is a linear function, right? That's what we're studying currently. And depending on the type of function, there are various strategies you can use to graph your problem, but this methodology will always work. You can always plot points. I require a minimum of 5. I suggest you do a couple negative, 0, because funny things happen at 0, and a couple of positives. So we have -2, -1, 0, 1, and 2. Where did I get these numbers, right? That's always the question. Granados, where did you get these numbers? Well, I got these numbers from the top of my head. I picked 5 small numbers that I know I can do the arithmetic with. I could use any 5 numbers that I want. But of all the ones that I wanted to choose, I like these ones. You know why? Because for me, it's easy. For me, I don't like calling things easy and hard usually, but it's usually easy for me to multiply by -2 versus I could have chosen -100, right? It's easier for me to multiply times 2 than by 100 or by 55 or by any other random number. So we evaluate 3 times -2 is -6, minus 2 is going to be -8. What this means is this is the point -2, -8. So we will go and plot that guy in a moment, okay? We have 3 times -1 minus 2, right? It's going to be -5. We have 3 times 0 minus 2, which is, of course, just -2. We have 3 times 1 times minus 2, which is just going to be 1. And we have 3 times 2 minus 2. So I just foreshadowed there, which is going to be 4. So now we have all these points. Let's graph them, right? So let's sketch our little coordinate plane. Don't need graph paper. I can just make tick marks. Okay. My vertical axis X, my vertical axis Y, my horizontal axis X. I have to go to the left 2, right, on X, and down 1, 2, 3, 4, 5, 6, 7, 8. I go to the left 1, I go down 1, 2, 3, 4, 5. 0, right? To 2, 1, 1, 2, up 1, 2, 3, 4. Now watch what happens. We are going to connect our dots because this is a continuous function, so we have to connect your points. Right? And what giving those discrete values just gives us effectively a sample of what this is going to have in this continuous function, because if for my domain, my domain for this is going to be all real numbers. I can put in any real number into this spot X, okay? This spot X, and it's going to have an output for me, okay? It's not a restricted domain in this case. So, for the f of x, one more of these guys, actually 2 more. F of x equaling 1/3 x minus 2, we're going to find the value of x where the f of x is equal to -4. Now guys, take a look at this. This is f of x, this is f of x, therefore these two things equal each other. Therefore, 1/3 x minus 2 has to be equal to -4. And it wants us to find, right, this x, which all we have to do is solve there, right? And now we're off to the races. Plus 2 plus 2, those guys are going to cancel. I have 1/3 x equal to -2, multiplied by 3, multiplied by 3, right? Those factor out, and x is going to be equal to -2 times 3, which is -6, and that is your answer. So, it's like they gave us the y, and then we solved for x, versus giving us an x, and we solve for y. Just work it the other way around. Okay. That's all I got for you for today. Go ahead and give the homework a shot. Good luck.